Now in this video, we'll review my process for calculating a confidence interval estimate for a mean, an average of interest from a population. And then we'll take the time for you to do some examples yourself, and along the way, we'll review the requirements needed in order for a confidence interval to have meaning, and the limitations of a confidence interval estimate in the first place. And we'll also review how to handle the problems of having small sample sizes and unknown population standard deviations, how that affects confidence intervals. So if you have any questions about the purpose of confidence intervals, or you're interested in a brief review, I encourage you to watch my other video called An Introduction to Confidence Intervals. And in the meanwhile, suppose here we have an example situation. Suppose you're needing to know generally how many close friends do adults generally have. And when we think about it, we realize we can never ask all the adults on the planet, so we'll maybe ask 31 people and get these 31 answers. These 31 answers, then I can add them all up and divide by 31 and find a sample average, a mean of 7. Now, also for the sake of practicing with calculations, we'll do something a little unrealistic. We'll assume that we happen to know our population's standard deviation. In other words, even though I don't know what the average number of close friends is for all adults, I do know that if I asked a random adult their number of close friends, it's most likely within plus or minus 2 of the real average. And this is not an impossible situation to know sigma, but it's very rare. Well, again, we're interested to know the real average number of friends that adults have, and we could say 7, but we're right or we're wrong. So instead of just saying one number, it's better maybe for us to give an interval, a window of numbers, where an answer would look something like the following, and we'll show what the following is, and let's see what we do. The steps to give a more accurate answer to this question than just saying the number 7. So here are my steps, and here's what we do, and the answer is ultimately going to look like this. The answer is not just going to be one number, it's going to be an interval. What I mean by an interval is 2 numbers where we think that the real number of friends for an adult is between. This number and this number would be the smaller and the larger number, what we think. Instead of just giving someone, hey, 7, I think it's between this and this. So how did I find these numbers? Well, here are the steps I went through. First of all, keeping in mind that a confidence interval estimate follows this general formula, this general pattern, that you have some number that you got from your sample, and then we're going to add to it and subtract from that number something we call the margin of error. And in the process, the first thing we really do is to decide the level of confidence, meaning the method that we're going to use for making this interval. You can see in the formula it includes a number. This z number, is the consequence of the confidence that you choose for your process for making an interval. So here, for example, suppose I decided I'm trying to make an interval of 95% confidence. Now you can look up in any statistical table the z number, the z value for 98% confidence, and the z number, when you look it up, here it's 2.326. So once I know this, and I start to think about the other pieces needed for this calculation, I need, looking at it, 1, 2, 3, 4 pieces. I see, okay, from step 1, I have the first piece. And the second piece is find that point estimate. Well, that x bar, if you will, that sample's average was 7. So I know x bar is 7. I also knew that the standard deviation is 2, and that I had a sample of 31 people. So what I do next is I find that margin of error. I find the z times the standard error. What do I do? Here's how I do it. The first thing I look for is I just find the standard error. So standard error, and we'll go over to the side here. This is where I did my calculations. Standard error, sometimes it's written in formula, it's written like this or like this. Same, just a different way of drawing the same expression. So the first thing that I do is I find the square root of n. I find, in this case, the square root of 31, and that number 5.56 is the number I'm going to divide underneath the standard deviation itself. I'm going to take 2, and I'm going to divide by that square root of 31. 2 divided by the square root of 31. That gives me the number 0.359. So that's my standard error. That's this piece of the margin of error. This piece. So here I have that 0.359, and as we said before, I found that this is actually my z number. So I take the z number and I multiply it by this standard error that I found, and so ultimately the margin of error that I find, the margin of error is 0.835. 0.835, and I rounded that to 0.84. It doesn't matter how much you round it or not. And so again, this interval estimate that I have right up here, this point estimate plus or minus the margin of error, I see now I have an interval built together, 7 plus or minus 0.84. And where do these two numbers, again, where do they come from? Well, this lower number, if I were to take the 7 and subtract 0.84, I'm going to get 0.62. And if instead I had taken the 7 and added 0.84, I'm going to get approximately 7.8. So here's the lower end subtracted element of this expression, and then here's the positive piece of the expression, the upper end of my interval. And my conclusion, the final conclusion, is a sentence to some extent, or at least a sentence in your mind that says, here is what I believe is the estimated real number of friends that an adult has. It's between these two numbers, and I've calculated it with a 95% confidence interval. So there are some requirements that needed to be satisfied in order for us to even do this calculation. So a few things to keep in mind. Now, our confidence intervals are built, this z number is determined based on rules, basic rules of probability. Now, if your rules of probability don't apply, then the whole method falls apart. I mean, this is why we need random sampling so that it's truly based on randomness, elements of chance, probabilities. And we also need to have each person's answer of a number of friends. Each person's answer has to be independent of the other person's answers. And so, if you will, the next important issue, especially here, if we don't have samples bigger than approximately 30, then the central limit theorem doesn't hold. That's also a law that allows us to use z-values, like we did in our calculated example. And another problem would be if we didn't know our population standard deviation. And while we haven't discussed why this would make it difficult to use z-values in our calculation, we can just take it on faith that this is an unknown sigma is also a problem. So if either one of these two is missing, then actually we still can calculate an interval. We can calculate an interval for small estimates as long as you have approximately or above a sample of 4 or 5. And also if the data doesn't show any very strong skew or strong outliers, which we could tell from our sample data by actually making a graph, a histogram. If you see a histogram and when there's a large skew of some kind or there's a strong outlier, then we'd have a problem. But as long as we have these bare minimum requirements fulfilled, 1, 2, bare minimum requirements in addition to requirements 1 and 2, then we're able to make a confidence interval estimate. If not, we're stuck. We cannot make a confidence interval estimate. And what happens in the case that you're not able to do this z-value and you use a t-value? Well, if either of those happen to be true, then what we'd be using is just a variation of that formula that we used in our example. It's roughly the same in that there is the point estimate, and then plus or minus, it's a margin of error, and that margin of error here, just replaces the z number with a t number. And obviously, if you don't have your population standard, you replace it with the sample's standard deviation. So we'd be able to still calculate a confidence interval estimate as long as these two basic facts are still known in addition to this. And as we can see from this, ultimately recognizing the study design is the most important step in doing statistical inference. So just to summarize what we just talked about is that to estimate a population's parameter, we give two numbers, an interval, it's called a confidence interval, and your answer looks something like this. And how I found those, well, the confidence interval is made of two things. It's made of a point estimate, and it's made of a margin of error. It's made of a point estimate. For confidence interval for the mean, should go like this, confidence interval for the mean is made of a point estimate plus or minus a margin of error, where the margin of error has these three numbers, 1, 2, 3. And above all, when we say this, 98% confident, well, this takes into account the fact that even if you do build a confidence interval, estimate, there's actually no guarantee, right, that the real average number of friends is actually inside that interval. So we can only guess based on the sample that we pulled, based on that sample. And we guess with a certain level of confidence. So more comments about this, more things for us to keep in mind, is that you find for formulas like this, it says more things to keep in mind, you find a t-value just like you'd find a z-value using tables or calculators, online resources. So if I were to have needed a t-value in the example that I just did, a t-value, I could use a table, such as a table. The answer, the t-value I would need would be this number. And how do I get this? I could open up a table, like this table, and I'd be looking in this table for, as it says down here, you can see down here it says confidence level. I'd be looking for a confidence level of 98%, and I look for a row, which is called the degree of freedom. I look for a row that is a number one less than the size of my sample. My sample here was 31, so one less than the sample. The row I'm looking for is the row that says 30. So I'm looking in row 30, and I'm going to move over until I see row with 98%, 7. That's where I get this number 2.457. So you would use a table just like, or calculator online, to find a z-value. In this case, that's 2.457. And the other important thing for us to keep in mind is that a confidence interval window, it only helps us to think about the spread, this between 6.8 and 7.8, or this spread only helps us to quantify uncertainty about sampling error, these natural differences in the population, well, in the sample you pull from a population. This window that we make doesn't take into consideration if you took a bad I guess you could say if you took a bad sample, or if you sampled a population, you didn't sample a population entirely, you took a sample that doesn't represent the population, or if you had other factors that influenced your sample. These are not taken into account with the margin of error from your confidence interval. These would make even more error in your you would need to have an even wider margin of error for a confidence interval in case any of these or more than one of these are true. So when I say also this non-representative sample, make sure that your sample is actually representative of your population, because otherwise you really can't draw conclusions about a population if your sample doesn't represent it. If I were trying to take or find a confidence interval estimate for all adults, then I should be taking a random sample that comes from all adults in the world randomly somehow. If I only take a sample of Americans or Boston adults, for example, then I couldn't make conclusions about all the adults. I could only make conclusions about Boston adults, for example. So in addition to that, one other thing, just to, as I was saying that I'd come back to talk about what's the definition of a 95% confidence. Now, I've said before, and I'm 95% confident about that. Now, what do I mean when I say I'm 95% confident about that? In other words, it's saying that there's a 95% chance that our method of calculation will produce an interval that contains the real means. It's very subtle. You shouldn't be saying just, I'm 95% confident that our interval contains the real mean. Because, frankly, once we've made an interval, either the interval has the mean in it, or it doesn't have the mean in it. I mean, it's either a yes or no. There's no probability about it. Statisticians would get very specific about this. And this is a very common thing that even many scientists confuse. So when you see the word 95% confidence, it means there's a 95% chance that our method of calculation produces an interval that does contain the real mean. It means how confident we can be that our estimation method produced a meaningful estimate for the real mean. So also, I'd encourage, if you're interested to know more or would like to investigate more, that Wikipedia's page on confidence intervals are fairly helpful. And let's try a few examples now, just to practice. Again, how do you calculate confidence intervals? How do you calculate confidence intervals when you have a known population and the population standard deviation, and hopefully also some point when you don't know that population standard deviation. So here we have two examples, and I'll take a minute now to pause and allow us time to read. I encourage everyone to pause the video and try reading these examples yourself and practice answering each one of these on your own, and then we'll go through solutions. Alright, so coming back, here we see a first question. Suppose we have asked a sample of 31 people. Again, 31 people. How many friends do you have? So then we can calculate an average from that sample. Turns out that that average number of friends is still 7. And again, we happen to know the standard deviation of the population, and it's still 2. Now here we're saying calculate a 95% confidence interval, not a 98% confidence interval. And for the sake of our calculations, I'm assuming that the scientists who did this did take a good random sample, good simple random sample, and that it happens to be that all people gave independent answers. Just things that allow our confidence interval to have meaning. So the steps that I did, again, let's just look at that first question. Steps that I did, and it says, okay, 95% confidence interval, I look up a z number. Why? Why did I do that? Since I have a known standard deviation. I should say this. Since I have a known standard deviation. And that I also know I have a sample n that's bigger than 31. So I can take this information, this n, this x, this n, this z, and I can, as I do, find this standard error. Find the square root of 31, then divide 2 by that 31, and get this answer here for the standard error, this answer which I'm going to multiply by 1.96. And then when I multiply those two together, I get the margin of error of 0.7, which I can then add to or subtract from 7. When I subtract 0.7, subtracting that, I get this number, 6.3. If I were to add that number, I would get 7.7. And so the conclusion that I could make, the actual answer to this question, something similar to the estimated real number of friends for Nerd is between this and this, with a 95% confidence level. And I'm 95% confident about that. Okay, and coming back to our second example, suppose we don't know the population standard deviation. We don't, in fact. So it says our sample standard deviation equals 8.1. So we were to have and ask 31 people, and these 31 people, then I do a calculation to find the sample standard deviation. Sample standard deviation, I find that that's 1.8. 1.8. So I find a sample standard deviation of 1.8. And then, thinking to ourselves, again, let's practice. Let's calculate a 95% confidence interval. But because we don't know this, or could also have been the problem if you hadn't talked to 31 people, if you'd talked to a smaller number of people, for example, 15, another example, then in both of those cases, like here, we need to use a t-value. And so what I can do in this case as well, I can go to an online resource. I can find that the t-value in this case should be approximately equal to that. 95% confident interval when I have a sample size of 31. Let's hope this is right. I open up a t-table. I'm going to look in row. I need to find a row, a degrees of freedom. This is the key idea. When I want a row, for finding this t number, I have to subtract 1 from 31. Subtract 1 from the sample size. This 31 minus 1, that 30 is the row that I'm going to use to find this t number, row. And then the column that I'm going to use, is this 95%. So if I look back at a table, I want to find the t number when I am interested in a 95% confidence level. At the bottom they say confidence levels. And I want it for a sample size of 31. So a sample size of 31 means a degrees of freedom, a row of 30. So I look over for 30 till I get to the column of 95%, and I get this number, 2.042. 2.042. So that's where this number comes from. A row of 30 and a column of 95. So then I take these statistics, these numbers that were given to me, and this number that I determined, and then I do my calculations the same as last time. I want to ultimately find a margin of error. I want a margin of error which I can add to or subtract from the point estimate, this 7. So I find this standard error. It's So take the square root of 31, and then I divide that standard deviation, the 1.8, I divide that by the number I found above, 5.56, I get 0.323. I get this standard error of 0.323. And the margin of error equals the t-value times 3.23. And if it's helpful to see, refer back to it here. I've got the margin of error equal to t point t. Bring it over here just so we can see this. Margin of error, which in this case should be t, times this whole piece here, this margin of error. Margin of error is this piece here, t times the number that we just found over here, the standard error, s divided by square root of n. S divided by square root of n. S divided by square root of n, which equals this number here. This number here times t. When I multiply them together, I get 0.66. So again, the steps for finding a confidence interval, always the same. I decide my level of confidence. That tells me the number I'm going to use. I take all these statistics. I find the standard error. I find this piece here. I find this piece here. For me, that's the second step, if you will. Then once I find this number, I multiply it by my t, and then I have my margin of error. I have my margin of error. And then that margin of error, I add to, or I subtract it from 7. I take that margin of error, I have 7 plus 0.66, I have 7 minus 0.66, and I get therefore 6.34 and 7.66, so that my final answer is the estimated real number of friends for an adult is between this and this. And this is my informal language of conveying that this is the t-value that was used, the 95% t-value that was used. A more formal language might be to say at the 95% confidence level. At the 95% confidence level. And in either case, this tells me that I am 95% confidence level. I'm just going to go like confidence, cond level. At the 95% confidence level, it tells me that I can have 95% confidence in the method of estimation I used. Perhaps helpful to see that again. It's again that there's a 95% chance that our method would produce an interval that contains the real mean. So here what we've done is an answer for number 2. Here's our answer. Here's our answer for practice question 1. And what we've done overall, again, is to look at the steps for calculating confidence intervals for a mean, and had a chance to practice some. We talked about the requirements that are needed for confidence intervals, some of the limitations on confidence intervals, the requirements, 1, 2, 3, and, or you could say even the most basic things, 1, 2, 3, 4. If you don't have these 4 things true, then you might have to then you might have to rely on someone else's knowledge, your own knowledge of the field of interest that you're trying to make an estimate about. If you don't have these 4 basic ideas, then we can't make a confidence interval estimate about our population. So, last but not least, I'll remind us the limitations. Some of the limitations on what we've just talked about is that the confidence interval doesn't take into mind if you have a sample that doesn't represent your population, if you have any other problems when it comes to how you got your sample. Those would be extra sources of error. So your estimate, your confidence interval window should be even wider if you find yourself having significant cases of these being included. And because if you're not careful about what your sample represents in terms of your what population your sample is representing, if you're not careful about that, you might end up only being able to make conclusions about the population that's defined by your sample. Even if you wanted to ask about all adults in the United States or in the world, if you only take a sample from, as I suggested, only take a sample from adults in Boston, then you can't make conclusions about the population of all adults from the United States or the world. So thank you so much for your time, and I ultimately recognizing that the study design is the most important part. Designing the study is the most important part about confidence intervals, about anything to do with statistical inference. So again, thank you for your time.